Hello friends, today in this video lecture we are going to learn Hermits interpolation formula. The interpolation formula so far considered make use of only a certain number of function values. We now derive an interpolation formula in which both the function and its first derivative value are to be assigned at each point of interpolation. This is referred to as a Hermit interpolation formula. Given the set of data point xi, yi and yi dash, and here I is equal to 0 to n. Then Hermitians h of 2n plus 1 of x is equal to summation I is equal to 0 to n ui of x yi plus summation I is equal to 0 to n vi of x into yi dash, where ui is equal to 1 minus 2 into bracket x minus xi li of dash xi bracket complete into li of x whole square, and vi is equal to x minus xi into ui of x li of x square, and li of x is equal to found by Lagrange's, and that is x minus x0 x minus x1 up to the term x minus xn upon xi minus x0 xi minus x1 up to the term xi minus xn, and which is the required Hermits interpolation formula. Then we see the problem of this type. First, find the third order Hermits polynomial passing through the point xi, yi and yi dash, I is equal to 0 and 1. Then first write the Hermitian formula. Solution. We know that the Hermit formula is h of 2n plus 1 of x is equal to summation I is equal to 0 to n ui of x yi plus summation I is equal to 0 to n vi of x yi of dash, where ui of x is equal to 1 minus 2 into x minus xi into li dash of x into li of x square, and vi of x is equal to x minus xi into li of x square. In this equation, put n is equal to 1 in 1. Put n is equal to 1 in 1, equation 1. We get, this is the equation 1. In this equation, put n is equal to 1. Then h3 of x is equal to summation I is equal to 0 to 1 ui of x yi plus summation I is equal to 0 to 1 vi of x yi dash, means put first 0 then 1, then equation become u0 of x y0 plus u1 of x y1 plus v0 of x y0 dash plus v1 of x y1 dash, and put the value 1 minus 2 into x minus x0 L0 dash of x0 into L0 of x square y0 plus 1 minus 2 into x minus x1 L1 of dash x1 into L1 of x square y1 plus v0 of x. Value of v0 of x is x minus x0 into L0 of x square into y0 of dash plus x minus x1 into L1 of x whole square y1 of dash. And now L0 of x is equal to x minus x1 upon x0 minus x1. That is equal to x1 minus x upon h, because minus is common, and x1 minus x0 is equal to h1. Then L1 of x is equal to x minus x0 upon h1, and here h1 is equal to x1 minus x0. Then L0 of dash x is equal to, differentiate this equation with respect to x, and this is equal to minus 1 upon h1, and L dash of x L1 of x dash is equal to 1 upon h1. Put this value in above equation. This is equation number 2. Put this value in equation 2, then we get h3 of x is equal to 1 minus 2 into x minus x0 into minus 1 upon h1 into x1 minus x upon h1 whole square y0 plus 1 minus 2 into x minus x1 into 1 upon h1 square, 1 upon h1 into x minus x0 upon h1 whole square y1 plus x minus x0 into x1 minus x upon h1 square y0 of dash plus x minus x1 into x minus x0 upon h1 square y1 of dash y1 of dash. Then h3 of x is equal to 1 plus 2 into x minus x0 upon h1 into bracket x1 minus x upon h1 whole square y0 plus 1 minus 2 into x minus x1 upon h1 into x minus x0 upon h1 square y1 plus x minus x0 into x1 minus x square upon h1 square y0 of dash plus x minus x1 into x minus x0 square upon h1 square y1 of dash, and which is required Hermits form. Then we see the next problem of this method. Write the problem. Determine the Hermit polynomial of degree 5 which fit the following data and hence find as approximate value of ln 2.7. Here x, y is equal to log of x and y dash is equal to 1 upon x. Value of x is 2. This value is 0.69315 and this is 0.5. 2.5, 0.91629 and this is 0.4. Let's see. 3.0 and this is 1.09861. This is 0.3333. Write the solution. Here x0 is equal to 2, x1 is equal to 2.5 and x3 is equal to 3 and y0 is equal to 0.69315, y1 is equal to 0.91629 and y2 is equal to 1.09 861. Here y0 of dash is equal to 0.5, y1 of dash is equal to 0.4, y2 of dash is equal to 0.3333. And Hermitian formula is the Hermits formula is h of 2n plus 1 of x is equal to summation I is equal to 0 to n ui of x yi plus summation I is equal to 0 to n vi of x y of I of dash, where ui of x is equal to 1 minus 2 into x minus xi into li dash of x into li of x squared. Vi of x is equal to x minus xi into li of x whole square. Put n is equal to 2 in 1. We get h5 of x is equal to I is equal to 0 to n ui of x y1 I plus summation I is equal to 0 to n vi of x yi of dash, and put here n is equal to 2 means 0 to 2 and 0 to 2. Then u0 of x y0 plus u1 of x y1 plus u2 of x y2 plus v0 of x y0 dash v1 of x y1 of dash plus v2 of x y2 of dash. That is the equation number 2. Here now we find the value of L0 of x. L0 of x is equal to x minus x1, x minus x2 upon x0 minus x1 and x0 minus x2. Here x is unknown, minus 2.5, x minus 3 upon 2 minus 2.5 into 2 minus 3. Here after calculating this we get the 2x square minus 11x plus 15. Then find L1 of x. L1 of x is equal to x minus x0, x minus x2 upon x1 minus x0 and x1 minus x2. After putting this value, x minus 2, x minus 3, 2.5 minus 2 and 2.5 minus 3. After calculating this, we get minus 4x square plus 20x minus 24. Similarly, we find the L2 of x. L2 of x is x minus x0 into x minus x1 upon x2 minus x0 into x2 minus x1. putting the value x minus 2, x minus 2.5 upon 3 minus 2, 3 minus 2.5. After calculating, this value is equal to 2x square minus 9x plus 10. Now we find the L0 dash of x, that is 4x plus 11. We'll differentiate this. L1 of x, differentiate this equation, we get minus 8x plus 20. L2 of x, differentiate this, 4x minus 9. Then find the value of L0 dash of x0, that is 4, and x is equal to 2. x0 is equal to 2. After calculating, this value is equal to minus 3. Then L1 dash of x1 is 2.5, then minus 8 into 2.5 plus 20, and this is equal to 0. Then L2 dash of x2, that is 4 into 3 minus 9 is equal to 3. And then find u0 of x. u0 of x is equal to 1 minus 2 into x minus x0 into L0 dash of x0 into L0 x whole square. Put the value of given 1 minus 2 into x minus x0 is 2. L0 dash minus 3 into value of this L0 of x is 2x square minus 11x plus 15 whole square. After calculating, we get 6x minus 11 into second bracket 2x square minus 11x plus 15 whole square. Similarly, we find u1 of x. u1 of x is equal to 1 minus 2 into x minus x1 into L1 of dash x1 into L1 of x whole square. Put the value of this 1 minus 2 into x minus 2.5. This value is 0, and L1 of x is equal to minus 4x square plus 20x minus 24 whole square. And after calculating, this value is equal to 4x square plus 20 minus 20x plus 24 whole square. And similarly, we find again the value of u2 of x. u2 of x is equal to 1 minus 2 into x minus x2 L2 dash of x2 into L2 of x square, and putting this value 1 minus 2 into x minus 3 into 3 into 2x square minus 9x plus 10 whole square. Then after calculating, this is equal to 19 minus 6x into 2x square minus 9x plus 10 whole square. Then find v0 of x. v0 of x is x minus x0 into L0 of x square is equal to x minus 2 into 2x square minus 11x plus 15 whole square. v1 of x minus x1 into L1 of x square and put this value x minus 2.5 into bracket 4x square minus 20x plus 24 whole square. V2 of x is equal to x minus x2 into bracket L2 of x whole square is equal to x minus 3 into 2x square minus 9x plus 10 whole square. Put all these values, which is u of x and v of x. Put all these value in equation 2. We get h5 of x is equal to 6x minus 11 into 2x square minus 11x plus 15 whole square into 0.69315 plus 4x square minus 20 plus 24 square into 0.91625 plus 19 minus 6x into 2x square minus 9x plus 10 whole square into 1.09861 plus x minus 2x square minus 11x plus 15 whole square into 0.5 plus x minus 2.5 into 4x square minus 20x plus 24 bracket square into 0.4 plus x minus 3 into bracket 2x square minus 9x plus 10 whole square into 0.33333. This is equation 3, and which is required Hermits polynomial, and put x is equal to 2.7 in equation 3 and simplifying we obtain ln of 2.7, and which is approximate to h5 of 2.7 and ln of 2.7 nearly equal to h5 of 2.7, and that is equal to 0.99325 means in this equation put the value of x is equal to 2.7, then we get this value ln of 2.7 is nearly equal to h5 of 2.7, and that is equal to 0.99325. Thank you.